Hi everyone. Let me know in the messenger if you can hear me. Oh, she's settling. Oh, cute. Not yet. We have to see Lyra big. Can everyone see? Can everyone see Lyra? She's actually joined. Oh, yay! Thanks, Zara, for telling me that you can hear me. Can't believe Lyra's actually here today. She doesn't normally make an appearance because she's out doing whatever cats do during the day. But here she is, and she's not even meowing yet. So that's really nice. Anyway, you're going to help us with organic chem, aren't you? So let's put the cat down. Ow, ow, claws. Okay, ow, claws. Please take your claw out. So we are doing advanced organic chemistry today. So I hope people were either present in last week's lesson or had a catch up, because I'm only going to be doing a brief catch up of last week's work so we can actually move on to drawing alcohols, carboxylic acids, and esters. So just to remind you, I'm going to start by drawing methane. Now remember, the ane tells you that it's an alkane. Here's its molecular formula. And now I'm going to draw its displayed formula. Remember that the meth tells you that it contains one carbon atom. Just to take an alkene now. So the ene tells me that we have an alkene. Eth tells me that we have two carbons. We know that its molecular formula is C2H4. So if I'm to draw its displayed formula, this is what we have. So like I said, I'm jumping in. Last week I taught you step by step how to actually come to the CH4, C2H4 steps. But remember, we are moving on quite quickly. Remember that a homologous series is a family of compounds. And so previously, we've met alkanes, alkenes, and now we are moving on to look at alcohols. Sorry about the noise, it's moronic, people driving outside when they shouldn't be. And then, oh my goodness. Carboxylic acids, and really it's the alcohols and the carboxylic acids that we're really interested in today. One thing to remind you of is that carbon atoms always form 4 bonds. There's 1, 2, 3, 4. 1, 2, 3, 4. Hydrogen atoms form 1 bond. And really importantly for today's lesson, oxygen atoms form 2 bonds. So when you start drawing your compounds, you've really got to make sure you remember these things, because if you don't remember this, then you're not going to get your displayed formula quite right. So, brand new stuff now with alcohols. Starting with 1 carbon atom. Well, we know from last week that 1 carbon is given by the prefix meth. Because it's an alcohol, the end of its name is going to be anol. So the first alcohol is methanol. So how are we going to draw that? Well, the functional group of the alcohols, so the special set of atoms which make it an alcohol, is OH. So somehow we've got to incorporate what we know about alcohols containing OH and the fact that we need 1 carbon atom. So here's the carbon atom. I'm going to draw the functional group straight onto it, and then it's a matter of filling in the hydrogens to make up the rest of the molecule. And so here we have our displayed formula, which is drawn like this. We can see the OH functional group. And it's actually better to use the displayed formula when you look at alcohols. If you start writing out molecular formula, it becomes quite difficult to understand which homologous series we're looking at. Okay, I hope they've gone. So right, the second alcohol, remember that we use monkeys eat peanut butter as our mnemonic to help us remember this. So monkeys was meth, eat stands for eth or eth. So the second alcohol, which you've probably most likely heard of, is ethanol. So if we draw that, we know that we have 2 carbon atoms. We know that we need a functional group of OH, and then it's just a matter of completing the molecule with hydrogens, making sure that each carbon atom has 4 bonds, each hydrogen atom has 1 bond, each oxygen atom has 2 bonds. 3 carbons now. Propanol, monkeys eat peanut butter, so peanut, propanol. We have 3 carbon atoms in a row. The OH functional group again. Complete the molecule. Ooh, who's unmuted? So one thing to be aware of here is the term isomer, which again I mentioned last week. Now isomers are molecules with the same molecular formula but different displayed. So why have I chosen to mention that at this point? Well, that's because the OH group can attach itself onto, as is the case here, the first carbon atom. Remember, we can flip the molecule around, which is why I'm saying it's the first one. And so we state where that OH is attached, and it's attached to the first carbon. If you're not happy, oh my goodness, if you're not happy with that being the first carbon, then I'll just rearrange it for you here. I promise this is exactly the same as what I just drew. So that's propan-1-ol, but we can see that there's an alternative place to attach the OH. We could attach it to the second carbon here. And still have a perfectly functioning molecule. So what's the name of this isomer? Well, it's propan-2-ol. So be aware that 2 isomers exist for propanol, both propan-1-ol and propan-2-ol. Remember, I can't add the OH to the third carbon and call it propan-3-ol because effectively you're back to propan-1-ol again. Can you let me know if you're happy for me to move on to carboxylic acids? This cat looks like Lyra. Okay, so moving on to our third homologous series, we've met alkanes, alkenes, alcohols, now carboxylic acids. Now the functional group with the carboxylic acids this time looks like this. So fairly similar to alcohols in that we have an OH group, but notice that we have a C double bond O. And so you're going to find this structure in every single carboxylic acid. However, how we build up the family of carboxylic acids remains the same. So we're going to start with 1 carbon. Monkeys eat peanut butter. So we know that the beginning part of this carboxylic acid will have meth in it. And then the ending is methanoic. It's ethanoic acid. And so that's how we build the name of the first carboxylic acid. This is going to be nice and straightforward to draw. We have our first carbon, the only carbon. We have the functional group. So we just complete the molecule. Remember, I told you each carbon atom must have 4 bonds. There goes the final bond completed with a hydrogen. And so that is how you draw methanoic acid. Moving on to the second carbon, 2 carbons this time. Monkeys eat peanut butter, ethanoic acid. So I'm going to draw my 2 carbons in a line. Let's add the functional group, which is all important for the carboxylic acids. Double check the bonds. Both carbons now have 4 bonds. I'll just show you. 1, 2, 3, 4. 1, 2, 3, 4. Each oxygen atom, has 2 bonds, 1, 2, 1, 2. And easiest to check is the hydrogens, they all have 1 bond. So as you can see, I'm constantly checking that my molecule makes sense. Moving on to 3 carbons now. Monkeys eat peanut butter, propanoic acid. Three carbons in a row. There's our all-important functional group. And now I'm completing the molecule. And there is propanoic acid. I think I'm going to just go straight into teaching you esters now. So the next homologous series, esters, which people do struggle with, but I promise I'll show you how you build them up. Now, crucially, these are a family of compounds which are made from both an alcohol and a carboxylic acid, hence why I just taught you what I taught you. So together you're going to have a particular alcohol, a particular carboxylic acid. What's going to take place is known as a reversible reaction, which you may have come across before. It has a special double-ended arrow, and it means that the reactants can react to produce the products, and then the products can undo and become the reactants again. But this isn't really what this lesson is about. So in terms of isomers of carboxylic acids, because of the way in which the COOH functional group attaches, you don't find that you can kind of add that group easily in the other part of the molecule. So going back to esters, we know that an alcohol and a carboxylic acid is going to produce an ester, and it's going to produce a byproduct, which is water. Notice that this is going to take place with a sulfuric acid catalyst. Again, not something that I'm going to go into now. That's not working very well, because I'm trying to show you how to draw these as opposed to talk about the ins and outs of reversible reactions, but it will take place in the presence of a sulfuric acid catalyst. Now, before I show you how to draw them, we need to understand how we're going to name the ester. So I'm just going to pick an alcohol, which is methanol. Just as an example, I'm going to add it to an acid, a carboxylic acid, ethanoic acid. And now we need to work out what this is going to be called. Now, notice that the first part of the ester's name comes from the alcohol. So let's have a look. We have methanol, which means that the first part of the ester's name is going to have methyl. So it ends in "-ile". It's just using the fact that it's methanol for us to understand that it's methyl. Now, the second part of the ester's name comes from the fact that it needs to contain an O8, and that O8 is going to come from, the beginning part of that name is going to come from our carboxylic acid. And so the name of this ester is methyl ethanoate. So what remains the same for all esters is that you have this kind of ending, thiol, and an ending O8. But crucially, the prefix comes from, for the first part of its name, from the alcohol, for the second part of its name, from the carboxylic acid. Just to show you the other way around so you can understand why it's so important, let's just flip it so that we have the alcohol ethanol reacting with the carboxylic acid, Methanoic acid. We know that the beginning part of the ester's name is going to come from the alcohol, so it's going to be ethyl. The second part of its name comes from the carboxylic acid, so it's ethyl methanoate. So hopefully you can see, even though it looks fairly similar, how the names have switched around. Is everyone keeping up okay? I know this is getting quite advanced. Thank you. But how are we going to draw these things now? So I'm going to get rid of the second example so that we can draw out the first example. Now, hopefully everyone's confident drawing methanol and ethanoic acid. In fact, why don't you all have a go now at drawing both of those out? I want you to draw the displayed formula of methanol and ethanoic acid. So methanol has one carbon. It's an alcohol, so it has the OH functional group. Complete the molecule. Ethanoic acid, eth, contains two carbons. And it has this very specific functional group. Complete the molecule. Now, when it comes to drawing the ester, we know that we lose a water molecule from those two molecules joining. So let's work out where we're going to lose the water molecule from, and watch this very carefully. You lose one of the hydrogens needed from the alcohol, and then you lose the OH remainder group needed from the carboxylic acid. And then effectively, because that's now disappeared, you join the remaining parts of the molecule together. So draw that extremely carefully. Take time to do it. I'm constantly looking back to make sure I'm drawing this right. And now we need to double check our bonds. So I'm literally going through making sure that every carbon atom has 4 bonds, and every oxygen atom has 2 bonds, and every hydrogen atom has 1 bond. Yes, I'm confident that that's true. To point out the functional group for you of the esters, it's COO, so it's here. This is, if you see a molecule with this sort of setup, then you know you have an ester. Just to mention one other thing, what type of reaction is this? Well, it's a condensation reaction because you lose a molecule in the process. And in this case,
Ocean man.
And in this case, it's water. So lots of things to be aware of. If you're going to be super accurate, you're going to remember that you have that reversible arrow. You're going to remember that you produce water as a byproduct, and remember to check all your bonds super carefully. Can you let me know when you're ready for me to go through a second example? Okay, I'm going to take you through a second example now, and then I'll let you guys have a go. In fact, I'm going to get you all to name the ester, just name it. And don't, I can tell you what, let's do it all together. Don't put it into the messenger yet, just press enter when I tell you, because I want everyone to have a go at doing this together. So try and work out its name. And then I'm going to count down, and I want you to write its name into the messenger. So in 5, 4, 3, 2, 1, press enter. Very good, guys. Well done. No one ruined it for everyone else. So its name is ethyl, because remember the first part of its name comes from the alcohol propanoate. And what's your spelling of that ending? Yeah, there's some slightly dodgy spellings going on. Make sure you've got that spelling nice and correct, but well done, everyone. It's very good. Okay, so now I'm going to show you how we're drawing that. Here's our alcohol, ethanol. Here's our carboxylic acid functional group. We know that it has 3 carbons because it's pro. I'm going to highlight where we're losing the water molecule from, so it's here and here. And then it's a matter of sticking together the remaining parts of the molecule. Yes, I have enough space for once.
That's water.
Yeah, I'm just still checking the molecule. Okay, is everyone ready to have a go at this themselves right from the beginning? No, I mean, if you think about whether there'd be an isomer for an ester, I mean, it basically depends on what isomers you're using for your how you're actually going to produce your ester. So that will dictate the exact structure of the ester, won't it? If you've got propan 1-ol or propan 2-ol, or if you have methanoic acid or not. So that will, you don't have much choice with your ester because you've got to build it from whatever compounds you've been given. Okay, so you have lots to do now. You're going to work out the name, and then you're going to draw out the entire displayed formula of how this ester is going to be formed. Okay, let's do a countdown from 5 with the name of the ester again. So make sure you've written the name, but don't press enter yet. Okay, 3, 2, 1. Very good, everybody. Very, very good. Okay, so remember the first part of the name comes from the alcohol, which is why it's ethyl. The second part of the name comes from the carboxylic acid, ethyl methanoate. Okay, let's draw this bad boy. Right, 1 carbon because you've got meth. Here's the functional group of the carboxylic acid. Complete the molecule. Now we have an alcohol, eth, 2 carbon atoms. The OH functional group. Complete the molecule. Reversible arrow. Work out what atoms are going to hop off to produce our water molecule. Redraw. How did everyone do? Well done, by the way. How's everyone finding this? Because this is right at the end of the IGCSE chemistry course, so it's supposed to be like the most difficult chemistry topic for sure, because you know you've had to build on an awful lot of different things in order to get to the point where you can accurately draw out esters. So yeah, well done to everyone keeping up and managing to actually form your ester from, we've only been doing this, what, half an hour? It's good. Really, really good. India, I'm not sure I completely understand your question because there's only one C over here that I'm highlighting in pink that double bond O can attach to. It's not allowed to attach to over here because it's unrelated. To make sure that everything remains in the original position. Cool, I'm glad I could help. I was worried that that wasn't very helpful. Let's get you, okay, this is quite hard. Can you guys all have a go at drawing methyl propanoate? Synthetic polymers, that's a different thing altogether. That's making nylon, which is a different part of the organic chemistry syllabus. Okay, so this might seem quite a long-winded way of approaching this question, but I think you have to do it this way in order to make sure you don't make any mistakes. So first of all, you want to identify the alcohol that this was made from. So that's methanol. And the carboxylic acid was propanoic acid. And it's actually, sometimes words look weird to me. So let's draw those two starting compounds. So methanol, 1 carbon, there's your OH functional group. Your propanoic acid, 3 carbons in a line. And so really what this question is asking about is drawing the display formula of the ester which would be produced. So I like to draw it so I can see what's going to hop off there, and then I'm going to stick together the remaining parts of the compounds. I'm just constantly checking back. So yeah, in terms of what you're actually being asked, this is the answer. But I did everything else to help me get to there. Did everyone get that right? Yay, well done. And if anyone's finding this a bit too quick, it is a hard topic. So just go back and watch the YouTube video once we've uploaded it this afternoon, and then you can take your time and pause and really understand where the naming and the drawing comes from. Yeah, I mean, if you flip the whole thing, so you have 3 carbons on the left-hand side, 1 on the right-hand side, it should be fine to do that, because fundamentally it's the same. Okay, so I'm going to leave the lesson there. I'm really happy with the amount that we covered. Is everyone feeling better about esters and seeing that it's not as bad as it might initially seem from looking at the textbook? Good, that's amazing. Well done, everyone. I'm so happy you understand. I just want to show you that organic chemistry doesn't have to be your nemesis. It's just about following. It is easy now. I don't want to annoy people by saying it's easy. When you know how, it's actually pretty straightforward, because you can get 100% in these questions. This is actually advanced IGCSE at the moment, but organic chemistry does come up again in A level and IB, because it's part of the organic chemistry. You look at like ketones, aldehydes, etc. So it will come up again in advanced organic chemistry. But yeah, is organic chemistry at A level easy to understand? It's like this on steroids. So it's similar, but there's a lot of extra homologous series that you have to kind of get to grips with. But if it suits your sort of style of learning, kind of logical following steps through, then you'll enjoy organic chemistry at A level. Okay, I'm going to sign off now. Well done, everyone. That was, yeah, a tricky lesson, but I feel like you guys all did really well. So have a great day.